minus 6 parenthesis x squared minus 3x minus 18. Enter. Menu, window. I'm going to make it fit the data, so I'm going with A. All right, so it looks like it's touching it over here, but I can't really see everything. So I'm going to go to menu, I'm going to go to window, and I'm going to change the settings, and I just want to go to the X a little bit. So I'm actually going to do -10 and 10. And I don't think I need to go -85. Let's go -20 to +20 because to me those numbers make sense. Okay, here we go. So it is crossing once and it's tangent once. So crossing once and tangent once. The answer is B, and we are done. To do the short answers, what I'm going to do is I'm going to flip back over to the answer key because the answer key actually gives all of those answers right there. So for short answer number 1, here is our equation. And even if you ignore this part and you just look at the equation, you can graph it in your calculator. Ooh, Miss Blank dropped the phone. You can look at it in the calculator. And you can notice that our graph is here, and you can just find those 3 points on your graph. And then you're just sketching it. It's not very complicated. Again, on the key here, they're showing you how to do it mathematically. I'm telling you, don't do that nonsense. You don't need to do any of this nonsense. Type it in your calculator. When you type it into your calculator, you're going to get a graph that looks like this. The zeros you're going to see are at -4, +1, and +4. And then as x approaches -infinity, as we draw to the left, the p of x is approaching +infinity. We did this in class. As x approaches +infinity, as we trace to the right, what's happening? Well, we're going down. We're approaching -infinity. Okay? And then they want you to sketch the graph. That's purely it. That's all we want. All right. So let's take a look at those word problems that we had because I feel like you guys like your bonus questions. So let's take a look at the problem. So it says the graph of g of x is shown. Describe the transformations used to obtain the graph of g of x from the graph of its parent function and write a rule. We have practiced this several times, and the easiest thing to do is take a look at where the center is and identify h and k. So where is my center? It's right here. So on this graph, we go from -2 to -4. So this middle part is -3. And then it looks like these are all 1s. So we're looking at a -3, -3. So my center is at -3, -3. Okay? With that in mind, that means that my h is -3 and my k is -3. Perfect. So I use my template of b plus h equals the right-hand point, and a plus k is the y value for the most right-hand point. So I take a look at this. The first thing that you notice is this is actually flipped over from where it was before. So we're actually dealing with a negative number. So we're dealing with something over here instead of over here. So if I trace, the next actual point I get is this one right here. And that is at -5, +1. So -5 and +1 is the point that I'm going to use to solve. I'm going to plug in what I know about h and k. So that's b minus 3 equals -5 and a minus 3 equals 1. Solve. So now I have b equals -2. And I have an a that equals 4. So I have done a horizontal stretch of a -2. I have done a vertical stretch of 4. And that is what this graph is telling me. I've stretched it. So I've stretched it horizontally and I've stretched it vertically. So describe the transformations of the graph. So this was a vertical stretch. by a factor of 4. This was a horizontal stretch. By a factor of 2, and it was flipped horizontally. So it's flipped over the y-axis. That's the negative in there. It had a horizontal shift, left 3, and it had a vertical shift, down 3. So that's all the transformations that it did. We got the horizontal and vertical shifts right from the beginning with our H and our K. Then we picked a point that we could identify, plugged in our H and our K, found A and B, which gave us our vertical and our horizontal shifts or stretches. And that is number 1. Number 2, the perimeter of the base of a right rectangular pyramid is 20 centimeters. The height of the pyramid equals 3/5 of the product of the width and the length of that base. Write a simplified equation. What is the domain? Graph it over the domain. What is the max volume? Describe the volume. Okay, they have already solved this one for you in your answer key. So I'm just going to refer back to that because, well, they do all the work for you. So number 2, the perimeter of the base of your pyramid was a rectangle. So they took perimeter of a rectangle and they set it for 20 because that's what they gave us. So the length, if you solved for L, right, so if we subtracted 2W and we divided everything by 2, we would get 10 minus W. So my length has to be 10 minus W. So the base of the pyramid is W centimeters by 10 minus W centimeters, width times length. The height is, by definition, 3/5 of the area. Okay, the height is 3/5 of the area, which is the width times the length. So that's the height, that's the width, that's the length. So when you plug it all into the formula for the volume of a pyramid, which I will give you, do not hesitate to or have a panic attack. Volume of a pyramid is 1/3 times the width times the length of the base times the height. 'Tis done. When you actually multiply all of that out, when you simplify it all down, you end up with this equation. And then you have to analyze each piece separately. So just like in class, the W has to be bigger than 0. And the only other constraint is this 10 minus W also has to be bigger than 0. The length cannot be less than 0. So the width cannot be greater than 10. The width must be smaller than 10. So my width has to be between 0 and 10. So that's the only part of the graph they care about. Where is my max? Well, here's the peak up here. If you trace it down, it's sitting on the 5. So the maximum volume within that domain is where the width of my rectangle is 5. So the maximum volume of the pyramid is 125. That was the Y value on the graph. So it says as W approaches 0, the volume approaches 0. As the W approaches 10, because we said that was the end of our reasonable domain, it was reaching 0 again. The Y value was going to 0. So the volume of the pyramid approaches 0. The values of W approach the endpoints of the domain. That's all they're telling you there. All right. So if we want to go back and look at number 3, my game wants to play. If you take a look at problem number 3, sorry, I'm scrolling back and forth here today. Actually, go to problem number 3. The function, blah, 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 models the annual profit in tens of thousands of dollars for a small company from 2000 to 2010, where 2 is the number of years since 2000. State the function's domain and then the graph. They are talking about 2000 to 2010. So when I talk about the domain, my domain is starting in the year 2000 and it's ending in the year 2010. That is my domain. Domain is where T, in the number of years since 2000. So that means 2000 is 0. So that's 0 to 10. Doesn't make any sense to graph anything outside of that because we're not going above 10 years before 2000 and we're not going below 10 years before 2000 because that would be negative and we don't go back in time. So the function's domain is going to be 0 is less than x, which is less, or t, which is less than 10. That is our domain. I will write that down. Just 1 second. Miss Blank has to get it together. So part A says state the domain. So my domain is 0 is less than or equal to t, which is less than or equal to 10. That is my domain. Then I'm going to graph it and identify and interpret the zeros. Again, we're talking about annual profit in years. So if we're talking about an intercept, the zeros, where is it at 0? Well, this is where y is 0. That's when there was 0 profit. So we're looking at x-intercepts. We're looking at where did they make no money in that year. So let's see if my calculator's still working. Woohoo! Tab. I'm going to enter in my new equation. So we have the, that's not what I wanted. One over 63 parenthesis x plus 2, nope, parenthesis x minus 1, parenthesis x minus 7, parenthesis x minus 9. Okay, I'm going to hit enter, but I'm still going to mess with my window anyways. I want my window to start at about a -2, and I probably want it to go to 12 because I need it to go past the 10 so I can really look at things. Okay, so here we go. From 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm here. Okay, 10. What do my x-intercepts mean? So it looks like their profit has gone from no profit. They were actually owing money. After a year, they made 0 profit. So they've improved and they're breaking even. So then we're making some money and then we're losing some money. And right here, we're breaking even again. Then we've actually started losing money. We've turned it around and now we're broke even again and we're going up. So it's where we're breaking even. Where are we breaking even at? 1, 2, 3, 4, 5, 6, 7, and 9. 1, 7, 9. Okay? 1, 7, and 9. This one over here does not matter. We do not care. It's in the negative realm, and we're just looking between the numbers 0 and 10. And if you can tell, that's the 1, the 7, and the 9. And that's what it means. The graph of the function shows V in million dollars of stock portfolio over time in months. Guys, they're giving you the graph. All they're going to do is ask you, for what values of t is the function increasing? When are we going uphill? So that's from 0 until we hit this peak right here, which looks like 3. So from 0 to 3, we're increasing. Then we go downhill. And then right about here, so let's say 13 to 18, it's increasing. So for what values of t is the function increasing? For what values of t is the function decreasing? So we were going up, then down, then up. So we have 2 periods of increasing, 1 of decreasing from 3 to 13 months. And that's what you've got. Okay? That's my guess. Interpret the intervals found in part A in terms of the situation. So we're talking about a stock portfolio and valuation, right? It's the value. So the periods of increasing is when the value is going up, and the decreasing is the values when it's going down. That's really not difficult. Identify the coordinates of any local maximums and local minimums. Approximate the t values to the nearest half month and the v values to the nearest 0.25 millions of dollars. So identify. So I'm going to draw a dot right here. That looks like it is, I mean, if you really want to get technical, probably 3.5 months. I would call that a maximum. It's a peak. And it peaked somewhere between 2, 3, that's a quarter. I'd say 3/8. So 2 3/8 millions of dollars.